Good evening, everyone. I moved my mic a bit. Okay. Hello, everyone. Let me share my screen. And yeah, what should I start with? So, hi, everyone. And yeah, so today we're going to speak about one of the simple file formats. So some people argue that it's not a file format. So before Windows was an OS, it was a GUI launched from a system called DOS, MS-DOS, PC-DOS, Microsoft, IBM. And before that, there was CPM, Control Program Manager or something like this. And CPM only had COM programs, and DOS introduced exe programs. So COM is older. So executables, exe, like mzexe, are the father of P file formats. And COM is the even older parent. So it's like the COM's files are the grandparents of P file format, modern Windows format, let's say. But yeah, so first thing, this format has no official name. It has, at the time, because executables like the ancestor of PMZ executables had exec extensions. Those are the ones that were called executables, and .com files were called commands. So the word executable didn't mean that could be launched. It means specifically the exe files. And they were called programs, both of them. So basically, COM was called the COM programs, .com programs, and exe was called the exe programs. And in other ways, they were called commands and executables. So first, it's a format that doesn't have a very, very official meaning, and it doesn't even have a specification, even though it's extremely simple. I mean, probably the most simple of all. I mean, hardly how to do any. So basically, it has absolutely no structure. It's like it is. Let's take a. Oh yeah, I don't. Do I have a normal com somewhere? Actually, because I don't have any normal com anywhere. Let's see if I have some com files that are standard ones. Uh, I don't know. What do I have? I'm afraid. Oh yeah. Oh yeah. Of course, command com. Command com. It starts. There's no absolutely no structure. It could be just anything else. And IBM DOS.com. It starts. Okay, maybe E9 is always a jump, but basically this is not a requirement. So basically there is no file format. The execution starts directly at offset 0. It's pure code and data, let's put it that way. Execution will be it will be copied in memory, and it will be launched upon execution at a fixed address. Yeah. And so there's no way to identify a com file, and there is no magic, no structure, no whatever, which is quite a nightmare to identify. To identify com files, and there are FPs of weird files that trigger all the old school detections in antivirus because of that. So it's a format without any signature, without any structure, without any identification, which is giving a lot of headaches nowadays. I could also add that it's limited to 64 kilobytes for a full segment. It's not possible to, I mean, a standard COM doesn't, just the whole file is copied in memory and then blindly executed. That's the execution of a COM file. And yeah, that's about it. But there is one restriction that evolved over time. And if you've seen some of my previous talks, um, let's put it that way. The empty file here, the last.com, last is empty. You can see that last is an empty file. And if it will repeat. So if I launch something like debug, the good old debug. So okay, that's a debug, like the debug that we know. And if we run last.com, even though the file is empty, then, oh, sorry, typo. Oh, okay. last.om. Okay, it ignored the .om extension. Then debug is run again. Why? Because as I said, the whole file is copied in the memory, and then execution is started. And if the file is empty, then nothing is copied in memory, and execution is started, then it's the previous program that was running that is restarted with the current state of the memory that was before. So yes, because of course memory was not clear between two executions. So yes, that's in very old versions of DOS. Here it's a PC DOS 0.9. There was no check for the file size, and it's actually the same for CPM, the ancestor of DOS. You can reproduce that on many versions, but on more modern versions of DOS, then they added a file check. So again, no specification, but there is a tiny differences between versions. And by the way, the best part is that last.com, the reason I called it like, because someone found this trick and actually sold it. So he sold the empty file because it had a predictable and useful behavior of reproducing the last commands. So that's what we have for regarding the last file. I didn't mention that. I mean, not big deal, but still, um, master boot records, so the bootable sectors of the beginning of the hard disks, is also 16 bytes binary without any structure or identification. Therefore, it's not problem at all to do an actual COM master boot record polyglot, especially because with all the jumps and everything, the jumps will be relative, the calls and so on. So basically, even though the master boot record is not executed as same memory address as the COM file, it's very easy to do polyglot, and that's exactly what was done for. Let's see, what Janus polyglot, was it on GitHub? Polyglot. I illustrated a brilliant polyglot, much more than just COM file. At this address, accelerator/Janus, he added a lot of file formats altogether. It's a brilliant polyglot. ELF, C64, COM. I mean, what's the map? I made a map to rar zip. A brilliant polyglot, but also a small COM MBR polyglot. Okay, so MBR and polyglots and COM, same thing. I mean, not exactly same thing, but it's both 16-byte code started at the offset execution, started at offset 0 of the file. What else? So now we illustrated the fact that the empty file was running. Of course, in later version, it didn't run. Do I have an empty file here? Let's create one. Oh well, no, it might crash the software. I don't want to reproduce it. I remember one trick that impressed me when I was young. Is a game, Budokan. It's very easy when you were actually showing the content of the file, because basically you have control over every byte as long as it's executable. It's very easy to jump over some bytes, some data, and then clear the display and then add a 1A terminator. So with the game Budokan, that's what happens. There was this message, and if you notice, there is at the beginning there's actually just a small XOR loop, like no big deal. But then here, this is a single 0D. It's not 0D 0A. A 0D just not, it's not a line feed. It just returns at the beginning of the line. Because of 0D 0A, you have return of carriage return and line feed. So basically, with doing just a 0D, you just restart the cursor at the end of the line and you will override the display. Then the text starts, and then at the end of the text, there is just a character 1A, which is the DOS here, which is the way to stop a DOS text character under DOS. So basically, by doing these tricks and a jump over it, it was possible to display some text. And this is actually very easy to do yourself. So I created a small file. and this file is only, so D6. Oh, sorry, I'm gonna disassemble it a bit. So D6 is I chose a undocumented opcode, set AL and carry, because why not? Just to see that it will still run even though it's not disassembled by disassembler at the time. Then a small jump, and the jump is over my content, and my content, you see there is a 0D to clear the line. Then I typed I added the Ange just as a 0D Ange, and then 1A, and C3, which is return to stop the execution. So basically, Ange will work. It will not do anything. It will just jump over the text and then return. And if you type ange.com, it displays it because of the same trick. Okay, so as you can see, you would really have a full control of whatever is in the file, as long as the first opcodes are executed. And even here, a case of a slightly undocumented opcode, D6 set AL and carry. Yeah, so I would say that the most known file nowadays for how can I say, in COM files is the EICAR file, because the EICAR file is a COM file. This is why it was taken. So when you actually run it, it displays the string, and it's very clever because it's done with printable characters. The whole file is a string, and it's not. If you take an opcode table of x86, there are only a few characters that are possible to be printable. And if you notice, the jump is E9. So jump is E9. So basically, jump is not printable. So basically, we'll see that it relies on a jump greater or equal. It knows some default values on initialization, of course, but basically you cannot use. It's like writing a book without the E letter. Then here it's a small software without a jump opcode. C3 is returned. I mean, it's very easy anyway. We will see what it looks like. But yeah, that's the EICAR file is a DOS file, is a COM file, and basically, so you see that pop ex, so the first value on the stack is null. So basically, it initialize the ix value to something, then bx is set, and so on, and si is set, and then with all these values from here, oops, from here to here, it's just initializing stuff, and it will modify then two values, two word, sub bx si, and then move the pointer twice further. You cannot do a add, so you have to do ink because it's how do you say, it's alphanumeric, it's printable characters. So it modifies it initializes the values, then it will modify two words in memory, because of course it cannot do the operation it wants, display a string and finish execution with printable character, and then it jumps over the string. So we're here, and jump of greater or equal, as I said, because you wouldn't have a printable jump. And as you can see, it jumps over the string. So now, yeah, let's see what it looks like when you execute it. Not under PC-DOS 90. I tried under PC-DOS 90, and the debug version of that is not comfortable with self-modifiable code. So the sub bx si things will not work properly. I was with it. Yes, sub bx si will not be handled correctly in such an old version of debug. But in our case, on a more modern version, it works. So we just go to, oh yeah, so it's debug. So the opcodes are a bit, I mean, the commands are a bit different. To step, you don't have a step, you just have a trace. To step over only interrupts and maybe calls, it's called P for proceed. So if you use WinDBG, P is proceed. And yeah, that's about it. So basically all the from 100 to 114, this is initialization. So we'll go to 114. Now it tells us the status of the registers and so on. At EBX is where the modification will happen. So EBX is now 140, and we see that there is some ASCII, but it will be, of course, decrypted. I mean, decrypted, transform. It's not really encryption, but yes, turn into meaningful opcodes from ASCII, their ASCII values. So yes, so just let's trace a few T T T, and now we have instead the very classic. Oops, sorry, not dump, of course, but unassemble. I love that it's not disassemble, it's unassemble. And yeah, so you have a int 21, so a call to interruption 21 just to print the string with equal to 9. Or AL? yeah, I'm not so wrong. And in 20, which is an old school way to close CD20, we see CD20 is just a shorter way to terminate the process. So basically, this is exactly what's going to happen. Now we jump if greater or equal, and we don't want to go to in the interruption, so just proceed to just display the string, as you could see, and now the program is terminated. So now we went through the execution of a good old EICAR file. I mean, good old EICAR file. It's still used nowadays for detection, but the meaning of this weird structure may be lost. And yeah, it's pretty cool. And it is a COM file. So it's funny that a COM file is still actively widespread nowadays. Um, what else do I have? Let me know if you have any questions. No questions. Okay, so yeah, I think that's all I have today. Again, it's very short, but still there are a few interesting things to see. With COM-file, know what a COM-file is. There were officially eggs to bean, so tools to convert executables to COM and so on, and also the reverse, so the same kind of software the other way around. Um, yeah, this is a very simple format. It's important to know it because, I mean, okay, in the case of ACAR files, not so important maybe nowadays. But yeah, the problem, I think it's more important to see the problems of identifying a file format when it doesn't have a proper detection mechanism at all. It's now the EICAR profile proves that even a simple text can be totally ASCII, and it's the same for shell codes, right? There are shell code ASCII encoders. So basically, it wouldn't be a surprise that an entire text is actually purely executable and very hard to detect, to scan, and that way. So I think why this extreme simplicity shows us the problem of detecting, yeah, of detection, and that when you take such a decision, then the problem, is still present along. I mean, forever, but more or less. So yes, that's all I have for you today, and I thank you for your attention. Yeah, the excellent. We went through ACAR file, we went through test files, last.com, printable ASCII, printable x86 opcodes, a brilliant polyglot, Janus, the extreme polyglot, and yeah, thank you for your attention, and see you next time. See you. Bye bye. Thank you.